In this video, we are going to be learning about mass percent composition. All percentages relate a part to a whole. The part divided by the whole gives us a decimal value, which can be converted into a percentage by multiplying by 100. When we talk about mass percent composition, we are describing the mass of the element within a compound compared to the total mass of the entire compound. Mass percent composition can be calculated using either experimental data or molar masses calculated from the chemical formula. Let's begin with an example using experimental data. A compound containing nitrogen and oxygen is found to contain 1.52 grams of nitrogen and 3.47 grams of oxygen. Determine the percent composition of the compound. Notice that we are not given the chemical formula of the compound. Because we do not know the chemical formula, we cannot use molar masses from the periodic table. Instead, we must only use the values provided in the problem. The general equation for mass percent composition is mass percent is equal to mass of element divided by mass of compound times 100. We need to calculate both the percent nitrogen and the percent oxygen because the problem did not specify a single element. First, we need to calculate the total mass of the compound. 1.52 grams of nitrogen plus 3.47 grams of oxygen is equal to 4.99 grams of compound. Now we can calculate the mass percent of nitrogen as 1.52 grams of nitrogen divided by 4.99 grams of compound times 100. This gives 30.46% nitrogen. Following significant figure rules, this would round to 30.5% nitrogen. Now we can calculate the mass percent of oxygen. 3.47 grams of oxygen divided by 4.99 grams of compound times 100 gives us 69.5% oxygen. An alternative way to find the oxygen percentage is to recognize that all percentages in a compound must add to 100%. So 100 minus 30.460 would also round to 69.5%. Now let's calculate the percent composition of hydrosulfuric acid. For this problem, we need to translate the name into a chemical formula so that we can calculate the molar mass. This compound is an acid, meaning it contains hydrogen ions. The prefix hydro tells us that this is a binary acid, meaning there is no oxygen present. The root name tells us that the anion is sulfide. Sulfur forms a 2 negative ion, so we need 2 hydrogen ions to make this compound neutral. The chemical formula is H2S. Now we can calculate the molar mass of this compound. Hydrosulfuric acid contains 2 hydrogen atoms, 1 sulfur atom. The molar mass is 2 times 1.008 plus 1 times 32.07, which gives us a molar mass of 34.086 grams per mole. Now we can calculate the mass percent of hydrogen in this compound. 2.016 grams per mole hydrogen divided by 34.086 grams per mole for the compound is equal to 5.914%. Now we can calculate the mass percent of sulfur. 32.07 grams per mole divided by 34.86 grams per mole for the compound times 100 gives us 94.09%. You can double check your answers by making sure the percentages add up to 100%. When doing this, make sure that you also include the mass of the entire element, so 2 hydrogens in the numerator for hydrogen. Mass percent composition can also be used as a conversion factor. Carbon dioxide is 72.71% oxygen by mass. How many grams of carbon dioxide contains 10.00 grams of oxygen? The mass percent equation tells us that the mass of oxygen divided by the mass of carbon dioxide times 100 would be equal to our mass percent composition. Rearranging this equation shows us a relationship between our mass percentage value provided and 100. This can be used as a conversion factor in our dimensional analysis. Every 100 grams of compound contains 72.71 grams of oxygen. We can set up our dimensional analysis starting with our 10.00 grams of oxygen. We can place grams of oxygen in the denominator of our conversion factor and then match to our conversion factor we found earlier. The 72.71 belongs in the denominator, allowing our grams of oxygen to cancel and giving us grams of carbon dioxide. 10.00 grams of oxygen is found in 13.75 grams of carbon dioxide. Using mass percent composition allows us to solve problems like this using dimensional analysis rather than relying on algebra.